Swayam Prabha. Digital India. Educated India.
Chlorine is widely used to disinfect water and eliminate pathogens. The points of delivery, like taps or reservoirs, must have enough residual chlorine to continue protecting water from contamination during distribution. But how can we ensure that? To find an answer to this, today's ACITE winning team has come up with a solution. Let's know all about it. So, welcome to the studio, guys.
Hello, sir.
How are you doing? Please tell us something about you to begin with.
Great, sir. And it was nice. It's going nice.
Hello, sir. My name is Atavi Devnath, and I'm from Civil Engineering Department. And here is
Amitabh Anand from Mechanical Engineering Department, and we are students from National Institute of Technology, Agartala.
and we're happy to be here with you.
Same here, Atabi and Amitabh. Nice to have you with us. So, to start the conversation, let us first of all try to understand the problem that you worked upon. What was that?
Yes, sir. If I am to explain what exactly we were supposed to bring for this competition or hackathon, to be precise, actually we were supposed to make a digital portable handy kit for testing silver, E. coli, and bacterial contaminants and some other bacterial contaminants, which is no such device exists till now.
Okay.
Currently, what we do is we use water sample. We collect water samples from areas and we send it to labs, and from there we get the results. But no such digital device existed till date.
Okay, so right now it's happening, but it's happening through a longer process in which you have to collect a sample and send it to the lab. So that is the main issue as per you, right?
Yes, and it is costly too. Whether you do it in the lab or not, it is costly. Even there are sensors available for E. coli bacteria, but that is too much costly. It costs around 1 lakh to 2 lakhs.
Okay, so to tackle that, you decided to, develop a kit which could do it instantaneously at that particular point only, and also reduce costs. So now let us get to know what exactly did you work on? What exactly did you make?
I would like to tell you about the sensors that actually helped us for this project. We used AS7341 spectral sensor, which measures the wavelength through 11 channels, and and we processed that reading, and we present the output on display screens and speakers as well. Whether the water sample is potable, or let's say is it safe to drink or safe to use or not.
So right now, what we do, we take a water sample, and we have two testing procedure. One is through a strip based, and one is test tube based. So in the strip based procedure, we dip the strip in the water sample, and it changes the color according to the concentration of suppose silver ion or chlorine ion in water. And then we take the strip and put it inside the gear kit, our water testing kit, and then through the spectral sensor AS7341, it detects the color of it and the wavelength of the color, and converts it into the concentration that is in ppm through the algorithm we made, and then it shows the user in the display screen, OLED display, about if how much concentration of chlorine or silver ion or E. coli ion it has, and whether the water is safe or unsafe to drink or not. We have, as per the instructions, we have above 2 ppm of chlorine ion in water, the water is not safe to drink. So we measure that and put that output to the user only. Apart from that, we have added one speaker. The reason to add the speaker is, suppose in rural areas where people are blind, they cannot see the display output we're putting. So the speaker will help them to listen to the output in their own rural languages.
Okay, that was very thoughtful. So I can clearly see there is a hardware component and there is a software component. So how did you divide the work? Is your team well equipped to handle both the spectrums? Like who did what?
Yes, sir. Actually, I'll tell you about my whole team. We divided the task that consisted of a couple of domains. We had members from electrical engineering department, civil engineering department, chemical engineering departments. So everyone collectively had our works divided. Let's say, be it the research portion, be it working on sensors, the electronics or the circuitry portions. And apart from that, we had a lot of research on the chemistry of the whole process, means what the problem statement actually was. So combining these all domains, we created, and yes, also there was CAD models to be made that we developed. Our team members developed those models as well. So collectively, we designed our final product or the kit, what we call Giri kit.
Wow, so that's a very good collaborative approach, and you, I'm sure, did it very well because that's, what happened. You went on to win the competition. Wonderful. So, okay, now another thing that comes to my mind is, did you go through any kind of a testing when you created this kit? Did you actually go to the point of distribution at different, points and actually check it on the field?
Actually, sir, that could not be done before the competition itself. We did it in the during the competition, and the mentors in SIH. They helped us a lot to think about the different perspectives where it could go wrong. Our cricket could go wrong, and maybe detect wrong concentration of water. So what we did is we took various samples of water as well as we disturbed the samples too to make it easy or to see if Girkit is convenient enough to test all those disturbed samples as well as various water samples too.
Okay, so you actually did sampling and testing during the hackathon only, and that gave you a kind of right results, right?
Yes, our algorithm was quite strong enough to beat it.
Okay, so what was the feedback from the mentors, and what was the kind of interjection from the judges? So when you went on with this project of yours, how did that go? I mean, were there any things that you needed to incorporate as per their suggestions or observations?
Yes, sir. So there were a lot of instructions or a lot of guidance we got from them, and that helped us to improve our kit a lot. Means it, as we already know, it's a 5 day long journey. Means it's quite hectic. It became quite hectic for us to work throughout the day and night as well. So the mentors and their guidance helped us a lot, and we worked on a lot of portions. We improved a lot of segments, which eventually got us to the final product. We got a lot of setbacks in between, where actually, if I go on telling, on the fifth day or the final day of presentation, we got a microcontroller burned. So that actually completely lost our confidence. Ki what we'll be doing, what will our presentation be, and how will we present ourselves finally. But things got sorted eventually because we had that intent of getting into the work or getting the things sorted. So at the end, things were quite good, and we end up winning the competition as well.
Wonderful. Hats off to your grit that despite setbacks, you were able to, bounce back and make it, not only make it, but win the competition. Wonderful. So, okay, while talking about SIH, let's hear from you the experience that you had in those 5 grueling days. What kind of experience did you go through?
Actually, before deciding that I would like to participate, we as a team in SIH, I was most excited about the rigorous 5 day, day and night we're going to be spent together because I wanted to experience that, and this is one of the reasons that I pursued SIH too. So the experience was really amazing because some things were expected for us, some things were unexpected. Especially our nodal center was Galgotius University, and the hospitality we got from Galgotius was extraordinary.
Yes, sir. And adding to what she said, the food there was quite good, was enough for us to work, and the management the volunteers involved in the whole process were quite commendable, and they did an appreciable job right there. They helped us in a lot of aspect, and in fact I should say in every aspect wherever we needed them, be it a day or night, whenever required. And we had a lot of other fun session as well to keep us motivated, to allow us work for those long hours. And so yes, at the end everything worked, and
Very heartening to know that it was a very wonderful journey of those 5 days in your nodal center, and the experience of SIH was very positive for you, and it was positive for us also because you came up with something really wonderful, which is not only usable but very beneficial. So it worked both ways. Great. So now coming to the future, where do you think this project of yours going from here? Can this be monetized? Can this be turned into a startup? Or do you think you still would like to, put some more efforts into this and refine it further? So what is the future for this now in your mind?
Talking about the future, sir, actually, after winning this hackathon, we thought and we had a discussions regarding this too. But right now, what we think is a lot of things need to be changed before actually getting this released in the market. So we need help from the ministry as well. We need a lot of R&D team. So we will definitely be working on it, be it not directly like a startup or something, but definitely we want to scale this and bring this on ground, because what we have created or what we were asked to create is something that's going to change how these testings and are being done. So actually we want to work on it, and we are in touch with some of the departments through which we'll be getting some help, and definitely we will be planning for it to get scaled.
Nice, guys. We are looking forward to this thing successfully getting implemented on ground, and you would really want to see this getting used by common people around, because it's going to be a great help for humanity all across. So thank you so much for joining us today and sharing your project with us. It was really wonderful, and you've done something really great. And hopefully we will see that this reaches masses and they're able to utilize it. So good job, guys. Thank you so much for joining and sharing your thoughts. Thank you.
Sure, sir.
Thank you, sir. Thanks a lot for making us revisit those memories.
And we're really glad that we are able to share all those things right now.
Yeah, and those are very valuable to us too. So thank you. Thank you so much.
Thank you.
Thanks,
Thank
sir.
you. Personalized testing kits for residual chlorine levels at delivery points can be very useful in ensuring safety and effectiveness of the water disinfection process, particularly in emergencies, remote areas, or during field inspections. Such innovations are need of the hour, and we are glad that our young innovators are on it.